Hey students, so the next topic is mass, force, and acceleration, which is Newton's second law. Okay, Newton's second law of motion. Newton's second law explains the relationship between mass, force, and acceleration. Here we have formula which is F is equals to ma. F stands for force, m stands for mass, and a stands for acceleration. So, this means that the acceleration of an object depends on the force applied to it and its mass. The greater the force applied, the greater the acceleration. However, the heavier the object, the more force is needed to achieve the same acceleration. So, basically, Newton's second law explains how force, mass, and acceleration work together. Okay? So, if you push something harder, it accelerates faster. Okay, so heavier object with more mass, you can say, are harder to speed up. You need a lot more force to get a heavy truck moving than a small toy car. Okay, so here we have example: pushing a light object versus heavy object. Imagine pushing a small light box and a large heavy box with the same amount of force. The box will accelerate more because it has less mass, requiring less force to move. Okay, light box has less mass. If you push it, it will fly forward quickly. Okay, like it high acceleration, you can say. Whereas heavy box has a lot of mass. If you push it with the same amount of force, it will move slowly, which is low acceleration. Okay, so here we have question that which do you think will accelerate more when pushed with the same force, a heavy box or a light box? Yes, the light box will accelerate more because it has less mass to hold it back. Okay? So the next one is amplitudes and wavelength of waves. Okay. Amplitude. The height of a wave measured from the rest position to the peak. It represents the wave's energy. Higher amplitude means more energy. Okay, so amplitude basically means the height. Okay, so this is the height of the wave from the middle to the top. It shows how much energy the wave has. A bigger amplitude means a louder sound or brighter light. Okay, so wavelength, the distance between two consecutive peaks or trough, you can say, of a wave, it defines the length of the wave. So basically, this is the distance from one peak top to the next peak. It tells you the length of one full wave. Okay? Waves type comparison. Sound waves travel through air or other mediums as longitudinal waves, have varying amplitudes and frequencies determining loudness and pitch. Whereas light waves, electromagnetic waves that do not need a medium to travel. Different wavelengths correspond to different colors of light. Okay? Okay. Okay. This is the graphical representation of waves. Look at this diagram carefully. So it displays waves with different amplitudes and wavelength. Okay, so one wave with a high amplitude and short wavelength, you can see that. Whereas another wave with a low amplitude have long wavelength. Okay,